Okay, now let's move to our next lecture. Till now, we have discussed about relational algebra and relational calculus. Now, this video I'm keeping for a practice session and we'll do it together. Okay, so there will be 10 problems on algebra, tuple relational calculus, and domain relational calculus. So, every query can be solved in 3 ways. Yes, so we'll see them one by one. Fine. So, okay. Now, let us see. See, we are given with 3 schemas. Now, you can understand it in this way also. That first schema is given as student, and its attributes are SID, which is a primary key, then name, department, age. In the same way, course, CID, title, credits. In the same way, enroll, SID, CID, and grade. Okay, and here you can observe enroll is one schema given for the where there is no primary key. There are only foreign keys. Yes. So basically, enroll is a relationship. Enroll links student to course. Yes. So in ER diagram, it will look like this: student, course, and there is this relationship enroll. And here we have one descriptive attribute grade, and its table will have the primary key of student and course, that is SID and CID, which will act like foreign key here. So this is our 3 schemas given, and on this now we will see some questions. Okay, so let us see this first question. So the first question is, list all the students in CSC department. Okay, we have to list all the students in CSC department. So this is our schemas given to us. Now try it by yourself first. Okay, list the students in CSC department. You can pause the video and try it by yourself. Yes. Okay, so the thing is, it is a pure selection query. Okay, so it will work with select. If I'm talking about relational algebra first, okay. So it is select command. Yes, and what we want to select, we have to select from which table. We have to select, list out all the students in the CSC department. So where is the department? Department is existing in the student table. So from here, we'll get the information. So we have to target this student table. Select from student table here. Yes, then what is the condition? Department should be CSE. That is the thing. Okay, that is the thing. So that is your answer. Easy. So now let's see second one with TRC. With tuple relational calculus, how it will work. So we have to first take one tuple because we want to display everything. So we'll just take a tuple T, and T belongs to which table? Student. And there is a condition T dot department. T dot department is CSE. I hope you remember these things. The syntax we have already discussed for all of 3 relational algebra, TRC and DRC. Correct. Now see, so here we are getting these tuples, the rows that are students with department CSC. Now let's try third one. I hope you are getting this. For any doubts, please drop the comments. So DRC. So in domain relational calculus, now first we want to display everything. So we are giving name to them. SNDA. That is our names. So we have to give it in the form of SNDA like this. Okay. So instead of T, we have to mention all the columns which we want to display. And here we are displaying everything. Then again, SNDA. They all belong to which table? Student. They all belong to student table. And the condition is out of all of the columns, the D column, department is equals to CSC. Okay, so that is an answer. I hope you got it. It's easy to understand. I hope you can get such type of queries. So these are your answers which are written over here. Yes. So this question is of pure selection. Fine. So let's move to next one. Second question is list the names of all students. Now we want to just list out the names of all students. So let's see how we will do that. So first try it with relational algebra. Again, we have to list out the names. So here we want to project only the name. So the thing is we want to just project the name first thing. Okay. Yes. And then of all the students, there is no other condition given. So from which table we want to display these names? From the student table. Your answer is here. This is your answer. Let's try TRC. This time, let me write all of three together. Okay. So let's try TRC. So with TRC, first we have to choose T. T is a tuple. Yes. And in this T row, we want to just display name. So T dot name, first thing. Then after that, this T belongs to which table? That is your answer. Done. Your answer is done. Okay. Okay. Now here DRC introduces something important. When we will talk about this DRC, now something important will come here. If you have thought of, okay, what? First we want to display the names. So you will just write N. Correct? First thing. Now what will you do? You have to mention all the columns instead of N. Yes. So there exist S, D, A. Yes. And then you will mention this thing S, N, D, A, they belong to student. So it is necessary to mention the other columns also. Out of all the things, out of all the columns, you are just displaying N. Yes. So we only output the name N, but the row has 4 fields. Correct now? So the other three, S, D, and A, must be bound by there exists. So you have to mention that. So that there exists for the columns, you don't output is the DRC habit to internalize. That is the way DRC works. Whether you are displaying them or not, if you're displaying everything like in the previous query, then you will write down all of them together. But if you're not displaying, you have to bound them with there exist. And you have to mention the pending column names. Correct? I hope you got it. Yes. So that is the thing. So this is the answer. I hope you got this. For any doubts, please drop a comment. Let's move to next question. So this is our third question. Display the names of students older than 20. Yes. Okay. Yes. So here condition is also there and you want to project the names of the student. So what you will do? First relational algebra. You want to project what? Name. So first thing. Then after that, there is a condition and you have to select what? Who are older than 20. So that means we are targeting the column age. Age should be greater than 20. So from which table? Student. We have to select this condition from which table? Student. First thing. Okay. Then you have to give the condition. A should be greater than 20. That is your answer for relational algebra. Yes. Okay. Correct. Now, what you have to do? Now, the next one. You just have to append one condition in TRC, like in the last one. Okay. That age is greater than 20. So you'll write down the same in the same way. Like what? T dot name and then T belongs to student. And then you will write down and T dot age should be greater than 20. So that is your answer. Okay. I hope you got it. Yes. Now in the same way, if you'll try DRC, correct. Again, we want to just display name. So again, you write down just name and you will bound other columns with there exist first thing. Then you will give your condition S and D A. They all belong to student and then one condition will happen and and your age A is greater than, that is your answer. Okay. So that's the thing, students. Yes, I hope you got it. So that is your answer. You can check it. And the best way is pause the video on the question, try the answer by yourself, and then check out the answer. Okay. So let's move further with question number 4. So question number 4 is you have to display the titles of courses worth more than 3 credits. That is the question. Okay. So what we are going to do, see what is happening in this one. Now we want to display the courses. It is a identical pattern to question number 3, just on course instead of student. Now this time we will be targeting titles of the courses. So we want to display the title. Okay. So what will happen? By title. First thing, we want to display that. Then what is the condition? We are choosing the data from which table? Course. And then condition is credits. Credits should be greater than. That is your answer. In the same way, can you frame the answer for TRC and DRC? It is the same pattern. Yes. So I'm showing you the answer and you can match your answers. Yes. So yes. So we did the same thing. We want to display the title. So C dot title. And we chose instead of T this time, we chose C. That is fine. Okay. And then C belongs to course and C dot credit should be greater than 3. Yes. In the same way, you have to see there are three. There are three columns. Yes, out of which we want to display one. So in DRC, we have given the name to title is TI. Yes, and first name is CI and CR for CID and credits. Yes, so you have to bound the pending columns with their exist. And then what you will do? You will give all the column names together belongs to course and the condition CR is greater than 3. So that is your answer. Let's move to question number 5 now. Now medium level came. Okay. Till now we have seen some easy level questions. Now it's medium level questions are there. Yes. Now let us see this one. Name of the students enrolled in course C101. Name of the students you will get from student table. Yes. And who are enrolled in the course, that is course ID. So course ID you will get from course. So what you have to do? Here we are utilizing two tables. So what you will do? This needs join. This needs join. Okay. Name is a part of student table. Enrollment lives in enroll in that way. So the thing is CID is coming from course. Now another thing. It has given one more keyword, enrolled. So what you will target? Will you take this table or this table? You will take this table because it is containing both things, SID and CID. Yes, so you can match them. Which SID belongs to which CID? So that will come from enroll. Okay, so let's see. How will you perform this join? So one thing is clear. You are performing join on which two tables? Student and enroll. Okay, let me clean it and write it for you in relational algebra first. So see, in relational algebra, how you will write down. First thing is clear. We are performing student join enroll. These two tables, between these two tables. Now there is one condition also. We want to just project the names. That is one thing. Okay. Inside that we are performing join. So from where we will get the CID? We'll get CID from enroll. So there you have to perform select also. So you'll perform select and you will give the condition as CID is equals to C101 from the table enroll, and on this data you will perform join with student. Okay, now see how calculus will do a join. This is still I feel it is easy as compared to TRC and DRC. Now see, it will be a new thing for you to do it to do join in TRC and DRC. Okay, so now let's see that. So this is your answer for relational algebra. Now let's move to TRC, tuple relational calculus. So what will happen in this one? Yes, So here we have to utilize again there exist. So the first thing is clear. We are taking the name as S first for the student table. So from student, we are displaying one thing, student dot name, S dot name. We want to display that thing first. Now the condition, the query part. This is the projection part. Yes. Now coming on to the selection part, how it will work. So first thing you have to tell is S belongs to which table? S belongs to student. Now you will give for enroll. Now you will introduce enroll in this query. And so you'll give and there exists an E which belongs to enroll. Yes. And here is the condition you will give. There exists an E which belongs to enroll. And inside the brackets, you will give the condition. So what is our condition? Your E dot SID should be equal to S dot SID and E dot CID should be equal to C101. So what happened? What just happened here? See, it is a natural join. Yes. So when we perform join, because in relational algebra we did natural join. So what is the condition for natural join? It matches the common attribute. So what is the common attribute? SID in student and enroll. So by default it will give the matching components of both student and enroll. Yes. So what will happen? That's why we have written E dot SID should be equal to S dot SID. First, it will perform the join utilizing this. So this part is performing the join. Okay. So that's a join. Okay. So it will assert a matching row, the existing matching row. Yes. So that's the case, students. Yes. So that is the thing. You can go through it once again and let us see the answer. Now, same thing your DRC, domain relational calculus, will do. Yes. How it will do that? Let's see that. So there exists as join in the single most important pattern in this whole video. Yes. Okay. Now see this one. See, it will reuse the variables just. So we want to display one column that is n. Yes. Now there exists some other columns. Yes. What are those columns? S, D, A, and J. So see, I'll show to you. S, D, A, and G. Okay, these are those ones which are the pending ones in combination of both because we have to utilize join in this. Okay, that's why. So G is for grade. So S, D, and A is the are the pending columns of the student table and G is the pending column of the enroll table. So you have to show them all. Now S and DA they belong to student and now the condition comes. S. So three things. S, that is a pending one. Your C, CID, that is, it should be C101 and then grade. Okay. So S already we told it belongs to the student. It is SID. And then our another condition C should be your CID should be 101. So you have to give it here and then grade for G because there is no condition for that. They belong to enroll. So in this way, you have to write your queries. Okay. I hope you got some understanding. With more practice, you'll get more clarity on such things. So let's see further the next question, the sixth question. Now, sixth question. Name the students who got grade A in any course. Okay. Name the students who got grade A in any course. So it's the same shape as question number 5. So what is happening over here? Let's see. We'll first do relational algebra. Okay. So it will work in the same way. What will happen in this one? The condition changed to grade this time. Instead of CID, we will be targeting grade. That is the only difference. So first try it by yourself. I'm not going to write it over here. I'll just show you the answers and there we'll discuss. So it will work in the same way. Okay. So pause the video, try it by yourself exactly like question number 5, and then here are your answers. So see, name the students who got grade A in any course. So what will happen? In relational algebra, you have to project the names like in the question number 5. So pi name. Then you are performing join between student and enroll, and this time selection is on grade. That is the only difference. Again, the same thing. S dot name, S belong to student, and there exists an E which belongs to enroll. And the condition is, again, we have to perform the join by matching the common attribute SID. E dot SID is equal to S dot SID. And this time we are checking the grade. I hope you got it. In the same way, this time you will give, instead of CID, you will give grade value. Great. Okay. So I hope you got this. Now let's move to next question. So next question is, you have to display SIDs of students in CSC or EC. That is the question. Who belongs to CSC or EC? So here one thing changes. Or. So we will utilize or. Yes. Okay. So what will happen in this one? It is again the similar kind of stuff. Okay. So we'll see how it will work. So here the or thing is extra added. So what will happen on the condition of algebra, you have to write down department. We are targeting department. Yes. And then department is either CSC or department is ECE. That will change from student table. And then you have to display SIDs. So that is the only change. So it is not that difficult. Let's see. That is the thing. Okay. So or you have to utilize. Okay. So again, you are projecting SIDs, and selection you are doing from the student table, and you are doing a condition department CSE or department EC. Now in the same way, you will represent it in the TRC. So see what is happening. You will take, again, we have to display only SID. First thing, this T belongs to student, and then we have to give the condition, and the condition is T dot department. It should be either CSC or T dot department ECE. Yes, so it is already written. So that is your answer. In the same way, you will do in domain relational calculus. First, you will give the column which you want to display, that is SID. We have given it name as S. Then you have to block, you have to bound the other pending columns with there exist and DA are pending. Yes, and then you will give S and DA belongs to student, and then the another condition D. That is department. Department is either CSC or department is EC. Because here we utilize only one table, so I hope you can do it by yourself. Okay, so now the 8th question. Last 3 questions will take it as a difficulty, as hard. Okay, so let's see. What is the question? You have to display the students, name of the students not enrolled in any course. Now here the keyword that is not. So you have to focus. Okay. Now the word not changes everything. Yes. So algebra can't just select a negative. It uses set difference for that. It uses set difference for that. So all student SIDs minus the SIDs that appear in enroll, that will happen in this one. So let's see what will be the answer in relational algebra. Okay. So what you will do? First you have to do what? You have to perform set difference operation minus. Okay. Yes. Okay. So the thing is, first you will perform minus operation on SIDs of student minus SIDs of enroll. First thing. Okay. That you will do first. Okay. Then you will do what? Because we want names of the student, it will come from the student table. Then after this, you will perform join. with student table. And then finally you will project the final names. So that is the thing. Okay. But in calculus, what will happen? It utilizes one notation, that is negation. This is a notation that will be utilized. So negation, there exists an E, belongs to enroll. And in that one, you just have to give it simply like before, join s dot sid. Okay. So in the similar way, DRC will work. So that is the thing. Okay. So see here. For DRC and CRC, for TRC and DRC, you can simply write down this part first and then append negation on it. Okay. That will work in this one. In the same way for DRC. But in algebra, you have to utilize set difference. Okay. So that is the thing here. I hope you got some understanding on this. Okay. So let's move to our next question. That is ninth question. Now we want to display what SIDs of students enrolled in both C101 and C102. Both. So here we have to take the common data. Yes. So with common thing, what will happen? We have to utilize intersection. Both. Okay. So that we have discussed. Let us see that how it will work. So see, in this one, what will happen? The SIDs taking C101 intersected with the SIDs taking 102. So what you have to do? First, you have to perform selection and intersection. So you will select from enroll. So because you are targeting enroll, and you will take again enroll. Yes, select from enroll. What you are selecting? One time CID is C101 and another time CID is C102. So from enroll table, we are selecting this CID. Yes, but we want to display the SIDs. Both are part of enroll table, so no need of two tables. Correct. So what you will do? You will project SIDs of this one first, and then you will project SIDs of this one. And then what you will do? You will simply take intersection of them. Common of both. Fine. Now in case of TRC in case of TRC, what will happen? It will utilize two there exist for this condition, intersection. Yes. Okay. So there exists a C101 row for this student and there exists a C102 row. Both equals intersection in algebra. Yes. So whenever you see the word both, it means intersection. And that means two there exist in calculus. So it is intersection in algebra. Two there exist in calculus. Yes. So or was for union. You can use both is for intersection, not is set difference. Now let us see their answers. See, this is your answer. So see what is happening. We performed first this part completely, then performed this part, and we just appended intersection in between. In the same way, what you will do in this one, you will utilize two times there exist. So see what is happening. We want to display SIDs from enroll. E belongs to enroll and E.CID is 101 and there exists an F belongs to enroll where F.SID is E.SID and F.CID is C102. Okay, so that is the thing. And see this one. In DRC, what we are doing? So in relational calculus, again, so in domain relational calculus, as we discussed, there exist will come two times. Yes. See what will happen in this one. So we want to display only SID. So S for that. Then what is pending? Grade. Because CIDs so we have to mention. So only one is pending, grade. Yes. Now see here. First time it is 101. Another time it is 102. They belong to enroll. They belong to enroll. And because we are utilizing enroll two times, so we are giving G1 and G2. And there exists a G2 for enroll second time. So in this way it works. So some queries will definitely confuse you. So you have to practice it out a lot. Yes, the more you will practice, the more you will get hands on it. Yes. So let us see our last question. Yes, SIDs of students enrolled in every course. So as we discussed, whenever the term every or all comes, that means it is a division case. It is a division case. So what will happen in this one? Let us see. So algebra division will work in what way? You have to select SID, and because we want to check the course, so for that CID, and both are existing only in one table, that is enroll. And then what we will do? We will take CID and course. So basically we have to take enroll table first, and then we have to take the another table, C course table, and we have to perform division on it. So SIDs of students enrolled in every course. So we are utilizing these two tables. So division will be performed in this way. Okay. And calculus finally will use here for all. So that also will come. Now, till now we have utilized only there exist. But for all, we'll wrap everything. For all courses, there is a matching enrollment. Okay. So this is the trickiest and hardest one which can come in the exams. So first one is direct division. But how it will work in calculus? Here you will utilize for all. So what you will do? E dot SID that we want to display as our answer. So E belongs to enroll. And for all C which belongs to course, now you have to give a condition. You have to perform this join. Yes, there exists an F which belongs to enroll again, and F dot SID should be equal to E dot SID. Okay, because here we are checking enroll. Yes, so we have to perform this common of both. Yes, and then F dot CID is C dot CID. That is the thing. Okay, and here how it will go for all these columns, they belong to course. There exists a G. There exists a G where SCIG belongs to another enroll. Okay. So that is the thing. So the single word every will utilize division, and then in calculus you have to use for all for that. That will solve the question. Yes. So that's it, students, for this video. You saw some questions, selection and projection, joins with there exists, set operation, negation, division with for all. Okay, so you can drop the comments for your doubts, and keep practicing relational algebra and relational calculus, and gradually we are moving towards SQL. Okay, so thank you, students, for watching my video. Thank you for subscribing. Thank you to become my family. See you in the next video. Bye bye.